In this video, we will be talking about evaluating logarithmic expressions. So if you're asked to evaluate a logarithm, remember that we still have the option always of rewriting a logarithmic equation as an exponential equation. So if that makes it easier for you to think about these questions, right, we can think about this statement log base 2 of 16 equals what? That's what we're looking for, right? This is equivalent, if we switch it to an exponential statement, as saying 2 raised to what power would give us 16, right? Because remember, these things are inverses, logarithms and exponentials. So as long as we keep the same base of 2, right, all we're doing from one equation to the next is we're taking our input and making it the output, right? And then the output, which in this case is what we're looking for, is the same thing as the input in the exponential statement, right? And so this one is a little bit easier to think through perhaps, and so we know that we would have to raise 2 to the 4th power to get 16, so that means that is the output of this logarithm. Right, so our answer would be 4. Right, so remember, you can always just think of this as asking you, what power would we have to raise the base 2 to in order to get 16, right? And our answer is 4. Okay, so if we look at another one and ask that same question, right, this is asking us what power would we have to raise 9 to get 1 over 81, right? And to get 81, we would have to square it. So since we have the reciprocal of that, right, 1 over 81, that means we need to have a negative exponent, right? And remember, you can always check this by switching it to the exponential as well, right? So our claim right now was that log base 9 of 1 over 81 is negative 2, right? The equivalent exponential statement would be that 9 to the negative 2 is 1 over 81. Right? And if we believe that that's true, that means that our answer here must be true as well. Okay, and let's just look at one more. And this one is a little bit trickier just because the way it's written, right? So this is asking for log base 4 of 0.25, right? But if we think about what 0.25 is, right, that is equivalent in fractional form to 1/4. So sometimes you might have to rewrite it to think through this a little bit more easily. And now that I've written it this way, I can see this is asking me what power I would need to raise 4 to get 1 over 4, right? So that would have to be a negative 1 exponent because all we did was take the reciprocal. So this value of this log has to be negative 1. Okay. The other things you might see in this assignment are still evaluating logs, but those two special logs that we talked about, right? Common logarithms and natural logarithms. So remember, whenever you see a common logarithm, the implied base there is 10. So if it helps, you can write that in, right? And now we can see that what this question is asking us is, right, if we're looking for the output of this log, that's the same as saying 10 raised to what power would give us 100,000. Right, and you can see there are 5 zeros there. So this has to be the 5th power of 10. So log of 100,000 must be 5. Okay. And for this one, there is no, right, if you ask yourself the same question, right, 10 to what power gives you 1/4, there's no nice, easy number that we can come up with, right? And so that's why this one is giving you rounding instructions, right? And the fact that this is giving you rounding instructions is telling you to use the calculator, right? And remember, that's one nice thing about the common log and the natural log is they have a button on the calculator. So this one is really just asking you to make sure you know that exists, right? And to make sure you know how to evaluate this. Okay. So if we open up the calculator here, right, we just have to press the log button over here, which is right next to the 7, and then we'll type in our argument, or the input, which was 1/4 for this problem. And before I hit enter, right, we can think about what type of value we expect. So since our base here is 10, but the input was 1/4, right, a number less than 1, that means we should be getting a negative exponent. And we do, in fact, we get negative 0.602, right? So if we go back to the problem, it said to round to the nearest hundredth. So we would enter this as negative 0.60, right? If we're answering to the nearest hundredth. Okay, and it's the same thing for this last problem here. This is asking us to find the natural log, and again, it's telling us rounding instructions, right? Which means it's expecting us to use the calculator. So if we go to the calculator once again, we're going to hit the natural log button, which is right here directly underneath the log button. And then we'll type in our argument, 109 this time, right? And we hit enter, we get 4.6913, right? Going back here, it says round to the nearest tenth, so we would enter our answer as 4.7.